Hi everyone, welcome to lesson 6.6. I'm in the same shirt as 6.5, so you could figure that out. Maybe I'm doing two lessons in one day, or I just wear the same clothes every day. Here's your objective. I'll be able to use the distributive property, another property. We went over three yesterday, now we have another one, to compute multiplication problems mentally. Then, we have a second one actually. We're going to be able to rewrite algebraic expressions. All right, so we're going to do that as well. So we have this is two objectives, and it's kind of a three-parter. So stay with me, and I think you'll do a pretty good job. All right, first of all, what is the distributive property? Well, to multiply a sum by a number, multiply each addend by the number outside the parentheses. So I have 2 parentheses 7 plus 4. So it's really 2 times whatever 7 plus 4 is. All right, and I could do that mentally. I know 7 plus 4 equals 11. 2 times 11 equals 22. All right, but I want to show you there's a different way to do it, and it's through distributive property. Distribute kind of means to bring or hand out. All right, so I'm going to distribute this 2. Instead of doing 2 times 11, I'm going to do 2 times 7, and I'm going to do 2 times 4, and then I'm going to combine them. All right, so 2 times 7 equals 14. 2 times 4 equals 8. So now I'm left with, in those parentheses, 14 plus 8. And 14 plus 8 equals 22. So now you notice that there's two ways to actually solve this problem. All right? I can do PEMDAS and follow those rules, do my parentheses first, then multiply, or I can distribute and then add. All right, so it gives you a couple options when solving problems, and it'll help you in some cases when problems get a lot harder. The distributive property is your friend. All right, so let's solve this mentally using the distributive property, but show our steps. So I'm going to do it mentally, but I'm going to write it out because that's what it says for you to do as well. So first of all, if I'm going to distribute this, I'm going to do 9 times 4 and 9 times 1/3. So in my head, I basically see this. 9 times 4, okay, and then I'm going to add that to 9 times 1/3, because I basically just took apart my 4 and 1/3. I just made it 4 separate and 1/3, so that's why I'm going to add it. I took it away from each other, and I'm going to combine it after by adding. So 9 times 4, 9, 18, 27, 36, and 9 times 1/3 is really 9 over 1 times 1 over 3, which equals 9 over 3, and we can reduce that to 3. So 36 plus 3 equals 39. That is our answer. All right, it could be very easy to distribute this 9 times 4 and 1/3. It's an easier way to solve that problem. All right, the other way would have been to turn this into an improper fraction. 3 times 4 plus 1 over 3, then multiply. So now you see with the distributive property you have 2 steps or 2 choices to do now. If you don't like the distributive property, you don't have to do it later on, but for this lesson you do. So you can try it out and see if you like it. All right, let's try a couple more examples here. I have 5 times 2 and 3/5. So mentally, I'm going to be doing 5 times 2, which equals 10, and then 5 times 3/5, which we'll do in a moment, and then we're going to combine them. So mentally, this is how I would write it down. 5 times 2 plus 5 times 3/5. All right, so 5 times 2 equals 10. 5 times 3/5 is really 15 over 5. 15 over 5 because 5 times 3 is 15, and 1 times 5 equals 5. 15 over 5 can be reduced to 3, yes, because 5 goes in itself 1 time, goes in 15 3 times. So I end up with 10 plus 3, which equals 13 as my answer for that one. All right, down here, now I don't have a fraction, I have 2 times 3 and 6/10. So I could distribute my 2, I can multiply my 2 by my 3 and also multiply it separately by the 6/10. All right, so let's do that. so I have 2 times 3, and I'm going to add that to whatever 2 times 6/10 equals. All right, so 2 times 3 equals 6, plus, now I'm going to ignore the decimal for now. 2 times 6 equals 12, and I have one place value spot, so I make one loop, which is 1 and 2/10 or 1.2, and 6 plus 1.2 equals 7.2 or 7 and 2/10. All right? We're just breaking numbers apart, and we're putting them back together with the distributive property. All right, we could also use a distributive property to rewrite algebraic expressions. So I have 2 times, parentheses, x plus 3. Now I don't know what x is right now, but I could rewrite this. So I don't have to really solve for anything, but I'm going to rewrite it. So 2 times x equals 2x, because I don't know what x is. And 2 times 3 equals 6. So this becomes this after I distribute my 2. I'm distributing my 2 to my x and my 3. I'm multiplying it. All right, so down here I have 5 times 9 plus x. Okay, same kind of idea here. I'm going to do 5 times 9 first, then I'm going to do 5 times x. And 5 times 9 equals 45. And 5 times x is, well, it's just 5x. Because 5x, sorry, I don't know why I put equal sign there. 45 plus 5x. All right? 45 plus 5x is the same thing as these are both equal to each other, but that's when the 5 is distributed. Okay? All right. A lot of erasing to do today. All right, now here's the third part. So we've had 2 parts so far. The first part, if I go back, was using the distributive property to solve. The second part was using the distributive property to rewrite algebraic expressions. Now we're going to do something called factor in an expression. So this is kind of like backwards thinking. All right, this is not something that's, I would say, too important, but it really helps you think about things, makes you go backwards. So I have 12 plus 8. All right, I want to go backwards and figure out what a factor could have been. So 12 and 8 both have a GCF, the greatest common factor, of 4. 4, 8, 12, 4, 8. So I rewrote this as 4 parentheses 3 plus 2. So I went backwards from my distributive property, basically. So if I go back, if I use a distributive property now, I should be back to 12 plus 8. Let's see. 4 times 3 equals 12. 4 times 2 equals 8. And I'm back to 12 plus 8. All right, it's just backwards thinking, which is kind of cool, I guess. Let's try it out down here. I have 14 plus 28. I have to think of a common factor between 14 and 28. Well, I know 14 doubled is 28, so my greatest common factor is 14. So I'm going to write my greatest common factor on the outside. I'm going to multiply that by 1 and then plus 2. All right, so when I redistribute this now, 14 times 1 would equal 14, and 14 times 2 equals 28. So if I'm factoring, I just factored in that expression. All right, last one, I have an x here now. I have 4x plus 40. I'm going to work backwards. I know this might really sound confusing, but we'll get it. If I work backwards, now x and 40 don't have a common factor, but 4 has a common factor with 40, and that is 4. All right? So if I put 4 outside my parentheses, how did I make 4x? Well, it was 4 times x. All right? How can I make 40 by multiplying by 4? Well, 4 times 10 is 40. So when I factored in this expression, I have 4 parentheses x plus 10. Now if I distribute, it would be 4 times x, which equals 4x, and 4 times 10, which equals 40. Let's say I got this wrong, and I wrote 9 here. I could always check my work. 4 times x is 4x, but 4 4 times 9 is not 40, so that's incorrect. Oh yeah, 4 times 10 is 40. Okay? All right. So now it's your turn to do some work. You have 3 problems, and if you can't read the directions, I'm going to read them out loud closely for you. For A and B, solve using the distribute property. So for these 2 problems, distribute the 3 and distribute the 4. All right? For C, factor the expression. So you have 25 plus 6. You should end up with something outside the parentheses and 2 numbers inside the parentheses. And when you go back to redistribute it, it should turn back out to be 25 plus 60. All right, so I expect A and B to be pretty good. You might be a little bit confused on C. If not, great. We'll go over tomorrow, and you guys have a good night.